Coding agents have kind of blurred together at this point. If you lined up the terminals for Claude Code, Codex CLI, Gemini CLI, and a few of the newer ones and covered the names, most people couldn't tell which one they were looking at. They read the same files, run the same bash commands, edit the same way. The feature lists are basically copies of each other now. And then there's Pi, which goes in the exact opposite direction, and the people who use it get weirdly loyal about it. So I spent some time actually digging into it, reading the docs, poking at the repo, and I want to walk you through what it is and why it's built the way it is. Pi comes up most often as the thing that OpenClaw is built on top of. And the natural question is why? OpenClaw is a real product, so why not build it on Claude Code or Codex, which already ship with sub-agents, plan mode, permission systems, all of that? The answer is the whole point of Pi. It ships with almost nothing, and that's on purpose. Out of the box, Pi gives the model 4 tools: read, write, edit, and bash. That's it. No MCP support, no sub-agents, no plan mode, no permission pop-ups, no built-in to-do list, no background bash. If you come from Claude Code, that list probably sounds broken, like somebody shipped a half-finished product. But every one of those missing things is a deliberate choice, and once you understand the reasoning, it flips around completely. The person behind Pi is Mario Zechner, who a lot of older developers know as Bad Logic, the guy who created the libgdx game framework years ago. He's not a hype account. He looked at where coding agents were heading and asked a pretty blunt question, which is basically, why does the tool get to decide how you work? Most agents bake in a workflow and then hand you some settings to adjust the edges. You can tweak things around the harness, but you can't really change the harness itself. Pi treats that as the actual problem worth solving. Here's the part that makes it click. In a normal agent, if you want to add a hook, say you want it to write an audit log every single time it deletes a folder, you go into a settings file and you describe the hook in a format the agent already understands. The agent reads that config and runs inside its own fixed frame. You're filling in a form. Pi doesn't do that. In Pi, you write an actual TypeScript file that becomes part of the harness itself. It's not config that the agent parses. It's code that runs as a first-class part of the tool. You save it, you type /reload in the terminal, and Pi picks it up live without restarting. So the agent isn't just doing work for you, it's rewriting the thing it runs inside of while it's running. And you don't even have to write that TypeScript yourself, because Pi can edit Pi. If you want a new command, a new tool, a status bar, a different confirmation flow, you can literally ask Pi to build it, and it writes the extension into its own harness, reloads, and keeps going. That's the self-modifying part everyone talks about. The tool customizes itself on the fly. Peter Steinberger built OpenClaw on top of exactly this, wrapping Pi with the scaffolding it needed, the messaging integrations, the hosting, the extra pieces, either importing parts of Pi as modules or embedding the whole terminal interface. Pi gave him primitives, and he assembled the product. Let me get into how it's actually structured, because the architecture is the reason all of this holds together. Pi splits into a few clean layers, and each one only worries about its own job. There's a piece that handles talking to model providers. All the messy work of dealing with different completion APIs, Anthropic, OpenAI, Google, XAI, OpenRouter, and more lives in one place. Token tracking, tool calling, reasoning, streaming, switching providers in the middle of a conversation, all of it is contained there, so nothing else has to care about which model you're on. Then there's the agent loop, which handles the actual agentic cycle, validation, event streaming, running tools. And on top sits the terminal interface, the thing you actually look at, which renders the text, manages your sessions, themes, custom tools. The provider layer doesn't know about the UI. The UI doesn't know about the provider quirks. You can pull any one of these into your own app without dragging the rest along, which is exactly how something like OpenClaw uses it as a framework instead of an app. That provider support is genuinely one of the strongest parts. Pi speaks to more than 15 providers and hundreds of models. You can log in with a subscription you already pay for, like Claude Pro, or a ChatGPT plan, or GitHub Copilot. Or you can drop in an API key for basically anything: DeepSeek, Grok, Cerebras, Mistral, Bedrock, Llama running locally. and a long list past that. And you can switch models mid-session with a single command, Ctrl-L or /model. So you can start a task on a cheap, fast model, hit something hard, jump to a stronger model without losing your place, then drop back down. The messy compatibility work is hidden, so switching feels like nothing. The session handling is also different from what you're probably used to. In most agents, your conversation is a straight line. In Pi, every session is stored as a tree. You can type /tree, jump back to any earlier point in the conversation, and branch off from there in a new direction, and all those branches live inside one file. So if a task went sideways 20 messages ago, you don't start over, you rewind to the good point and take a different path, with the old path still sitting there. You can bookmark entries, filter by message type, export the whole thing to HTML, or upload it to a gist and get a link that renders the full session for someone else to read. For debugging and for sharing how you actually got somewhere, that's a real difference. Now back to all the stuff Pi refuses to ship, because this is where people either get it or bounce off it. Take MCP. Everyone's adding MCP servers right now, and Pi just says no by default. Mario wrote a whole piece on this, and the argument is pretty grounded. A lot of the popular MCP servers are heavy. They try to cover every case, so they hand the model a big pile of tools with long descriptions, and all of that eats context before you've even done anything. They're hard to extend, you'd have to go read the source and modify it. And they don't compose well, results have to pass back through the model's context instead of just chaining together. His alternative is the thing we've all been doing forever. Models are already great at running bash and writing code. So instead of an MCP server, you give the agent a small command line tool with a README and it just calls it. If the output is too noisy, you change the output format yourself in about a minute. You can chain calls in one bash line. You can save results straight to a file instead of pushing everything through context. It's more flexible than the rigid structure MCP locks you into, and it costs way fewer tokens. And if you really do need MCP for something, you can just build an extension that adds it. It's a default, not a wall. The other omissions run on the same logic, no sub-agents, but you can spawn Pi instances with tmux or write your own. No permission pop-ups, because Mario's take is that a confirmation flow should match your actual setup and threat model, so you run it in a container or build the exact gate you want. No plan mode, write plans to a file or add the feature. No to-do list, because his position is that those actually confuse the model, so use a plain to-do file if you want one. Every gap has an escape hatch, and the escape hatch is you or a package someone already shared. And that's the thing, extensions, skills, prompt templates, and themes all bundle into Pi packages you install from npm or git, so you're not always building from scratch. There's a real ecosystem forming, including some genuinely absurd stuff. Someone got Doom running inside it as an extension, which tells you how far the model goes, so who's this actually for? If your pain with existing agents is that they hide too much, inject context you can't see, make decisions on your behalf, Pi is basically the counter-argument to all of that. It trades convenience for control and for being able to inspect everything. If you want something that works great 5 minutes after install with zero setup, Claude Code is still the easy default, and there's no shame in that. Pi asks you to do more up front. The payoff is you end up with a tool shaped exactly like your work, instead of the other way around. The deeper reason I think this design is smart is durability. The harness layer of these agents is wildly unstable right now. Frameworks in this space get rewritten from the ground up, over and over, as the whole approach keeps shifting under everyone's feet. And a lot of the code people write today exists purely to work around what the models can't do yet. As the models get better at tool calling on their own, a chunk of that scaffolding just stops being needed and quietly turns into dead weight. By building as little as possible in the harness and pushing everything into extensions you own, Pi is basically betting on staying small. The less you bake in, the less there is to throw away later. It's a hedge against the fact that whatever's clever today is probably obsolete in 6 months. Pi's whole identity is defined by what it chose not to build, and in a space moving this fast, that restraint might be the most forward-looking part of it. If you want to try it, the install is a one-line curl from pi.dev, and everything is MIT licensed, so the only thing you pay for is whatever model you pointed at. I'll drop the links below. Catch you in the next one.